So I hadn't been feeling too well this past month, and the weather's been really awful. It's been really hot, so I can't be up in my room recording. So I've been experimenting with photogrammetry software. That's basically just taking a bunch of images of an object and turning it into a 3D model. And there's free programs out there like Autodesk 123D Catch. They even have a mobile app. But for me, these are too simplified and limited. I wanted something that was open source, so free, and that I could use commercially if I wanted to. So if I wanted to scan a sculpt and then sell the model, I could. And the only program I found that really did all this was this program called Regard 3D. And it also happens to have a really nice UI, so it's easy to use, and you only have to dive into the advanced options if you need to. More important than your software though is the images you take. So ideally you'd have your object and then you'd have a lot of diffused light, and you'd take your camera and you'd go around the object taking pictures. Now I couldn't really do this, so what I did instead was I took my two desk lamps, diffused them as much as possible, put up a white background beneath and behind the object, so that it could also spread light a bit. And then I kept the camera static and moved the object itself. And this works pretty well, but you can run into some problems. So for example, as the object moves, the shadows kind of change, and the highlights, so you can see the highlights around the forehead, keep moving because the lights are moving relative to the object, and that can cause artifacts when you're running it through the photogrammetry software. So anything that's too glossy can be hard to capture, and then if you have something like glass, that's almost impossible. You have to coat it in something, and there's special paints for that if you're interested. Also, as you might have noticed, I splattered ink all over the sculpt, so I didn't really care about the surface. If you do, you have to find something that washes off, because this didn't really wash off. And what this does is it gives the software a point of reference from image to image. So without it, it doesn't really do a good job of capturing something that's flat colored like clay. So I took 70 something photos from 4 different angles, and then I realized the area beneath the jaw and the hair on top was a bit sparse, so I took a few extras. And then you can see these here are in more shadow, and this doesn't really cause any problems for the model. But if you care about the texture, so you have something that naturally has texture and you want to keep that, so maybe like a toy or a person, the skin and stuff usually has enough texture for the software to work. But if you take images, if you have some of the images in darker shadows, that'll show in the texture. So be sure to diffuse the light as much as possible. Now, what type of camera you use doesn't really matter. What matters more is the lighting. But you should take them all with the same camera, and if possible at the same focal length, because you need that if you're going to do global SFM, which you probably are. And you can get away with a slight deviation in the focal length, so these were a slightly different focal length, but they still worked, but not too much. Okay, so now I'm going to open up Regard 3D. So this is Regard 3D, and you can see it has a pretty clean UI. We're going to start by making a project, file, new project, and I'm going to set the project path to my desktop project. And this is where the program is going to keep all its files, so everything it generates is going to be in here. And then the project name doesn't really matter, face. And then you can't see the OK button here because my font is turned up high, so I'm going to hit Tab, Enter. So this is our project, and from here we can add a picture set. So I'm going to go to Add Files, and I'm going to go to my desktop, Face Sculpt Images, and I'm going to select all these and add them. And then if I wanted to, I would add the extras. Okay, so here are all my images. I can preview them here on the side. It doesn't really matter if they're rotated the wrong way. And it should list your camera model here and the focal length. You can see these were slightly different, but most of these still worked. And then I'm going to give this a name, so I'm just going to give it a name set here and click that. Next, you're going to compute matches, and the program has a tutorial that goes more in depth into some of the options. I'm just going to go quickly because otherwise we could be here forever and kind of cover some of the stuff it doesn't cover, or what I learned from experience and some of the problems I found. So here the default settings work really well. I also found, for example, if you turn this more up, the computer likes to crash. So it's too resource intensive, but you can also turn this down and turn this up, and I got really good results with that as well. But the default settings work pretty well, and I would go ahead and hit OK, but this takes a while, so it could take more than an hour. So I'm gonna hit cancel, and I already have a project ready with everything that I've tried. So I'm gonna go to File, Open Project, Desktop, Face Sculpt Project, and this is the file you need to open, the .r3d. So I'm going to open that. So you can see here's my file, and you can see this is branching out a bit. So this is the really great thing about this program, is that for each step it records, for example, the parameters you used and the running time, so you can make a comparison between all the stuff you tried, and it keeps a record of all that, so that's really nice. Now, if you saved your file and when you tried to open it you got an error, that's probably because you moved your images. So never move any images that you loaded into the project, or even rename the folder or anything, because if you do, that's going to give you an error. You can fix this if, for example, so I'm going to go into project here, face, and I'm going to open this with Notepad. So if we take a look at this, this is all the info about the photos, and you can see here the image path is set. So when it doesn't find this, it throws an error when you try to open the project. So you could go in here and find and replace those if that happens to you and you move the pictures somewhere where you can't move them back. So I'm going to close that. So that's just something I found while I was about to do this video, because I moved everything to the desktop. So anyways, here's our project. Let's go back to this first step. So I tried twice, one with the first picture set and then one with the extras, and then we're at the matches step, and you can see right here the running time that took about an hour, and this is the one with the default parameters. So once your match is finished, you can click show matching results, or I don't remember if this pops up by itself, but you'll get this list of your images, and if you want to see the actual matches, you'll have to check show key points, and you still might not be able to see this. So I'm going to open the preview window, and I'm going to zoom out, and you can see all these little circles all around the ink splatters. So that's where it's getting all its matches. So now you can see how important that is. So I'm going to close that. And you can also see matches between image pairs. So I'm going to click show matches. And this might take a little while to load. And here we have all these lines. It should be covered in lines everywhere, to the point where you can barely see anything. So that's really good. We're getting a lot of matches. So we can just click OK. We don't really need to see that. Next, you're going to want to do triangulation. So basically, in photogrammetry, there's two major steps: creating a point cloud and then creating a mesh from that point cloud. And inside the point cloud step, you have two steps. One, you create a sparse point cloud, and second, you then kind of refine that and create a dense point cloud. Here, the sparse point cloud is called triangulation. So in the matches, you would hit here triangulation, and there's two options: incremental structure from motion, which basically you need to pick an image pair, and then it kind of stitches the other image pairs along. Now this doesn't really work well for me at all. It tends to crash most of the time. Global structure for motion works for me almost every time, and basically it's taking all the images and trying to match them at once. As for these options right here, I tried all of these in every possible combination, and they don't really seem to make much of a difference. Some will match more cameras. By cameras, I just mean images. Than others, but not by much, just by one or two, and that doesn't really make a noticeable difference. I'm going to hit cancel. I already have that done. And when that's done, something like this should appear. If you need to show it again later, you can click show triangulated points. And from here, we can also see our cameras. So I don't know if you can see it. There's a bunch of green little dots. You can make these bigger by going to the point size slider and going up a bit. So all those green dots are all the cameras that it captured, and it's counting here. 76 out of 83, so that's pretty good. So long as you get like 90% of more of the cameras, you're good to go. So once the triangulation is done, at this point from now on, you can export all these steps to other programs if you want to. But you can do the rest of it in here all the way up to the model, so that's really nice. Most of the programs are split into two parts, and it's kind of annoying. So I'm going to click Create Dense Point Cloud, and here you have two options, CMVS, PMVS, and MVE. Now this one, for me, I can't get it to work at level 1, it just crashes. So level is kind of like the resolution. With each level, it kind of halves the image. So here's more resolution, and here's less. I can get level 2 working, but if I compare level 2 to MVE at the default settings, I prefer how MVE creates the final model. It has a lot less artifacts. The only thing is, for MVE, you have to leave these at the values they are. If you touch this, I'm actually not sure what's really going on, because you just get a mess on anything but the defaults. So one crashes. This one also takes less time. So at level 2, this one takes like an hour, and MVE takes me like 3 to 4 hours. So whatever you decide to try, I would recommend in these time-intensive steps. It also gets very resource-intensive. It might even throw out memory errors, like your computer is running out of memory. Close these programs. So I would suggest you close all your programs before starting, and then just try to let it run overnight or over a few hours at least, so that it does its thing. Because sometimes it might recover from the memory error that it throws, and everything will just resolve itself. Other times it'll crash. And the cool thing about this program is it doesn't matter if it crashes. So if it crashes, everything that was saved is still saved. It'll just lose that step that you attempted. So that's really great. So I'm going to cancel that, and I'm going to show you. I tried all sorts of things, you can see. So I'm going to close all these. And this is MVE with the default settings. I'm going to show point cloud. This should happen by itself. And this will take a while to load the model as well, just because it's so many points. Okay, and I'm going to turn the point size back down. So this is the model, and I'm just going to move it a bit. It lags a lot because it's so big. And it's creating what seems to be a lot of artifacts, but when I actually run it through the surface reconstruction, it doesn't keep as many of these. So let's see, I'll compare it to CMVS, PMVS at level 2, which is the best I could do. So this is CMVS, PMVS, and you can see that it looks a lot cleaner, but I'll show you the surface later. And it's not, it has a lot of artifacts near the surface, so this would require a lot of cleanup to get looking nice. So I don't really like it. Also, if you use CMVS, you lose the option later to do a floating point reconstruction, what's it called? floating scale surface reconstruction. So you lose the ability to do that. You can only do poison. I do like poison better, but if you want to have more options, this is probably not the way to go. So these are kind of the defaults. This one's at level 2, of course. I can't do level 1. But then let me show you, for example, in CMVS, what happens when you go up. So turn up the level. So this is CMVS, PMVS with the level turned up. And you can see basically the resolution went way down, but it still looks pretty clean. Now for the MVE, so this is MVE with the scale turned up, and basically all it's doing is maybe creating a few less points, but it's creating a lot more noise. And I tried to fiddle with the filter width, but I don't really get any good results, and when you try to do a surface of this, it looks ridiculous. So this is a surface, and it looks like something out of your nightmares. I actually have a few that are worse. So look at this one. This is really awful. So I'm not sure what's going on there at all, and neither the pop-ups. So some of the options when you create a dense point cloud. So some of these, if you hover over them, it'll tell you what's happening, but it's really not very helpful. And the program tutorial doesn't really elaborate on what's going on here, so I'm not sure what's going on. Just the default works. So anyways, that's this horrific thing. So here's the regular one on the MV with default settings for comparison. So you can see this is really, really nice and clean. So I have no idea what's going on with the other ones. And then for comparison, here is a poison reconstruction with CMVS, PMVS. So you can see there's a lot more artifacts down here. That doesn't really matter. What concerns me more is these artifacts around the nose and the ear over here. Those would have to be sculpted out. And the other one, I didn't really have to sculpt anything out. It looked pretty good out of the box. You can also see there's some problems beneath the jaw, which the other one didn't really have. So that's why I prefer the MVE. Now you can reduce some of the artifacts created with CMVS, PMVS by fiddling with this threshold option. So if you put this up higher, you'll get less artifacts. If you put it up too high, the model will disappear. But you can fiddle with that. So I'll show you what that looks like. So I reduced the level here just so that it would take less time to compute. So this is what it looks like without with the default threshold, and then this is what it looks like with the threshold at 0.91. So you can see there's less artifacts, but when I create the surface, so I'm gonna show surface. This still has a lot of artifacts. So if I zoom in, there's still a lot of artifacts, especially in those problem areas that I talked about. So I still prefer MVE. But even so, if we go back here, if you are going to use CMVS, PMVS, because that's working better for your image set, I would also recommend unchecking use visibility information, especially as it recommends here if your photo set isn't too large, because if you leave this checked, it'll throw away a lot of your photos. As for the rest of the options, this one, cell size, is related to the resolution. It works similar to level. W size, it's kind of hard to describe what it does. You'd have to try it, and it doesn't really make any quantifiable difference, especially about the artifacts. Minimum image number is just so if a point only appears on 2 images, it won't use it. So you can set that here, and if you set it lower, it'll use more information from the images, but you'll get more artifacts, and if you set it higher, you'll get the opposite effect. And then finally, for CMVS, PMVS, you can choose the number of threads it runs on so that it doesn't slow your computer down as much, but I still haven't been able to get level 1 to work. Even if I lower this, it still crashes for me. Anyways, so that's the dense point cloud, and then after you have your dense point cloud, you can create a surface. So this is the default dense point cloud from an MVE calculation. And then here you can again export the scene to MeshLab, which is another popular free program for like cleaning up meshes and also doing the surface reconstruction. But I don't really like it because it's very convoluted and it also crashes a lot. There's a newer version, but I can't even get it to start, so I'm not sure what hasn't been fixed. I will just cover it briefly for the cleanup step, which you can't do here. But anyways, you have your dense point cloud, and I'm going to hit create surface. So here you have two options, poison surface reconstruction and floating scale surface reconstruction. I prefer poison, it's much faster, but I'll go through both. So for poison, the depth is kind of like the resolution. The only thing is if you go too high, you'll get a lot of detail, but you'll also get more artifacts. So 8 or 9 works pretty well. And then samples per node. If you have a really noisy sample, you'll want to turn this up a bit, but the default values usually work good. Same thing for point weight and trim threshold. The default values work great. If you turn these up, basically it just makes the artifacts around the base, for example, neater because there's a hole there and it doesn't really know what to do. So I turn those up just to have that a bit cleaned up beforehand. Now for floating scale surface reconstruction, again, levels are like the resolution. I'm not really sure what scale multiplier does because this step takes about like an hour to complete. And there's no lower level, so you can only get more detail. And at level 0, it takes an hour, so I really haven't had much time to experiment more than the few times I've done it. I can tell you though, the confidence threshold, turning that up improves the results, and also minimum component size, if you turn that up around 4,000, this one around, well, you can go to full, but if you turn these up, this one will reduce the number of artifacts, because basically it's telling it that there must be it must be at least this large to count as an object, so it'll reduce those little blobs it makes. And then for both of these, you have two colorization methods, colored vertices and textures. Now, colored vertices is faster, and it's also the only one that exports. So if you choose textures, you can't export it. I mean, it'll produce the textures, but the object file it produces will have an error when you try to import it into anything. So there's some sort of bug there. You could theoretically export an object using colored vertices and then maybe use the texture files from this, but it's much easier to just use the colored vertices. There's a way to view them in Blender, and then you can bake them into a texture if you want them. So I'll show you what that looks like after I'm done here. Also, another thing to note though, so colored vertices is faster and it's the only one that exports, but textures is the only one that will really let you see the model. So I'll show you what that looks like. Let me hit cancel. So let's see, this is poison reconstruction with depth 8. So that's what I usually start at because it doesn't take too long. You can see it only takes about 10 minutes. You can see it's really nice and clean. And here you can see that I use textures. So here I can uncheck show textures, and you can see the model and the detail really well. If you use colored vertices, so let's see, this one uses colored vertices. So here, if I uncheck show texture, nothing happens. So you can't get rid of this. The only way to see the detail is to really zoom in, maybe switch the shading model to flat so you can see all the polygons, and switch this to line maybe. So you can see, for example, around the eyeballs, it's a bit harder to see how much detail it managed to capture. And I'll also show you the default floating scale surface reconstruction, just so you can see what that looks like. So this is the floating scale reconstruction. You can see there's a lot more artifacts, especially here close to the ear, which would be hard to fix, and the chin. So the poison works a lot better for this. So anyways, once you have your surface, so let me go back to this one, you can export it and then you can open it in Blender, or if you want to clean it up in something easier, Mesh Lab. So I would hit export surface, and if you used textures, you'll only get the object option, and this won't work. You will only get the texture images. You won't be able to import this anywhere because it'll fail, like I said. But if you used colored vertices, you will get two options, PLY and Object. Object will strip any color information. This will not export with any texture images. So if you don't care about the texture, just export it as an object. If you do care about the texture, you have to export it as a PLY. So I have already done all that, and I'll show you what that looks like. So let me close this, and let's go into the project. You don't have to export these into the project. You can export them anywhere, it doesn't matter. So you can see object with textures. It produced this MTL file that's related to the textures, and it produced all the textures. But if you tried to import it anywhere, it would fail. And then this object with colored vertices, it didn't produce any of that. And the PLY, the color information is just inside the file, so it doesn't produce anything else. And now I'm going to use Mesh Lab to show you real quick how you can clean it up. Okay, so this is Mesh Lab, and to import our mesh, I'm going to go to File, Import Mesh, and I'm going to pick this PLY with colored vertices just to show you how it can keep the texture and re-export it. So I'm going to hit Open. And then real quick, I want to show you, for example, if you had a point cloud, you could import it too. And in here under filters, remeshing, simplification, and reconstruction, you can find the poison option that we used earlier. But the parameters are all different here, and there's probably a whole bunch of useful stuff in here, but it has really weird names, so you really have to know what you're looking for and or read a tutorial and the documentation to really understand what's going on. And also, like I mentioned, it tends to crash a lot, so I don't really like using it for that reason. But for cleaning meshes, this works really well. Blender would lag if I tried to rotate it like this. So to clean this, for example, this artifact over here, I'm going to rotate it so I can select it with a box as easily as possible. And then I'm going to click this icon over here, and that's going to let us select the vertices and click here to delete them. So you'd go around doing that for as many artifacts as you can. And then you can also, there's a hole at the bottom of the base, so to clean that up, you could select the base and delete it. So now we have a hole at the bottom here, and we can fill this here in Mesh Lab by going to this little icon, fill hole. And you only really get one try with this because it tends to crash, at least in this version for me. And self-intersection leaves a hole there. Trivial works a bit better. So I'm going to fill that and then accept and close that. And you can see it's, let me turn on the edges. So you can see it cut very weirdly, and Blender will do this too when it does the face. But here, as far as I'm aware, there's no tools to keep cutting a grid into here. So I prefer Blender, and I'll show you how to do that in Blender in a moment. So anyways, so that's done, and then let's go back to the other view. Now you might have noticed inside this fill hole dialog that there are other holes, and some of them are from artifacts that are floating around, and some of them are from the model. So this one over here, I believe, is the model, and I'm going to want to fill those just so that it's airtight. And if you turn on sculpting or something later in Blender, you don't get anything weird. So it can be hard to tell unless you've deleted all the artifacts first. So if you deleted all the artifacts first, you'll be able to know if it's a hole in the face or if it was an artifact, because you can't rotate when that fill hole dialog is opened. So anyways, from here, when you're done cleaning everything up, you can go to File, and don't click Export Mesh because that just overrides it unless that's something you want to do. Use Export Mesh As, and here we can give it a different name, so from Mesh Lab, and I'm going to click Save, and then be sure to leave color checked so that it exports that, and you would hit OK, and you're good to go. But you don't have to use that if you don't want. Let's go into Blender, which is also free. All of these are free and open source. Okay, so this is Blender, and I have my own custom theme and shortcuts, so I'm going to try to go through the menu items as much as possible so that you know where to go if you're not familiar with it. So first, I'm going to go to File, Import, and in here you should see the PLY and Object options. If you don't, you're going to have to click one of these little icons right here and open up the Preferences, so User Preferences. And in add-ons, you should search for the corresponding file type, so object, and check that, and it should load. So I'm going to go back to the 3D view, and I'm going to go to File, Import, PLY. So the object is just going to be just the mesh, so I don't really care about that. And I'm going to go to Face Sculpt Project. And this might take a while. It might look like it froze, but it didn't. Wait out like at least 2 minutes, 2 to 5 minutes before closing it. Okay, so there's our head, and I'm just going to delete this cube so you can see it. And the widget is in the wrong place, and this is rotated wrong, so I'm going to fix that, rotate this 90 degrees, and then I'm going to go to Object, Transform, Origin to Geometry, and that'll fix the widget, and then I can just place this in the middle if I want. So here's our head, and you might have noticed if you're familiar with Blender that I'm in material mode, but we can't see the textures, and that's because the vertices are colored, not the object, if that makes sense. So in the Properties tab here, I'm going to go to the Vertices tab, and if I scroll down, you can see here under Vertex Colors, we have this attribute called Kohl, and you can rename that if you want, do whatever you want. So to make this visible, we have to change the render engine to cycles. So once it's in cycles, this will probably change to white, and then we have to go into the node editor, and in here we're going to create a new material, and automatically it creates this diffuse shader, and I'm going to add input attribute, and from here we want the color node, so I put that to color, and for name we have Kohl. And now when I go back into the 3D view, you'll see we have our texture. So it's as simple as that, and then you can go ahead and bake this into a texture file if you want to save it that way. So I tried to record how I cut the base of the model and fill in that hole in Blender, which is what I prefer doing, but the program lags too much because there's too many vertices. So instead I'm going to show you with the sphere substituting as our model. So there's kind of two options here. One, you could grab the sphere and go into edit mode, and I'm going to assume now that you have some basic knowledge of Blender, because otherwise I can't be explaining every step. And I'm going to be sure that limit selection to visible is turned on, and I'm going to deselect everything and rectangular select here. Now you can see here there's a straight line right here, and this is not what happens with the model. So you're not going to get a clean cut like that. So to help emulate that, I'm going to turn this a bit, and I'm going to select the vertices again and delete. Okay, so when you cut the model, you'd actually get something jagged like this. And then there's, you can go in and select these with a loop select. But in the model, you won't get a perfect selection. You're going to have to kind of zoom in and connect them all. And then what you can do is under Tools, make Edge or Face. So that basically filled our hole, but it's really similar to the mesh slab solution, and it does not work well. If I were to take this into the sculpt mode, it would have problems around the edges. Even with Dino Topo turned on, this wouldn't work well. Now you can grab the knife tool and try to cut planes into this, and it will sort of work, but it'll be kind of hard to judge what's going on because the plane looks so flat. So instead, what I would recommend is, let's take this back a step before I made the face. So your model would really look something like this, right? So like that, and it extends upwards, blah blah blah. And let's go back into object mode. And what we can do is we can Boolean cut a plane along the bottom so that we get a straight line. So I'm going to go to create plane. I'm going to put this over the object. And then in a side view, I'm going to determine where I want to cut it. Be sure that it encompasses all the vertices. And then I'm going to select the object. And here in the properties panel, add a modifier, a boolean, and select the plane. And now you will get something like that, but we want this to be a union. So all the plane is doing is cutting the object. So I'm going to hit apply, and now I can delete the plane. But we still have a plane. You can see the plane merged with the object. So now I'm going to go into edit mode, and I'm going to select these 4 vertices of the plane and delete those. So now if you look at it from a side view, you get a really nice cut. This can be a bit hard to do with the model. You have to zoom in really far because there's so much going on. So ideally you would align this with the green Y line over here of the axis so that it's easier to see where you're selecting. So I'm going to select along here and delete that. So now we have a really nice cut, and we can loop select this really well, and we can make a face. And now we know this is perfectly flat, so that we can cut with the knife tool real easily, and it won't give us any errors. Because otherwise, sometimes it doesn't want to cut in the other way because the plane is jagged, so it doesn't really understand what's going on. And you're gonna want to make a grid of at least, I don't know, 9 by 9 or something like that, so that if you go into sculpt mode, you have something to grab onto. And it doesn't really matter if they intersect all over the place, so you can be real quick like this. Okay, so you're going to want to get something like that. And now I'm going to go into sculpt mode. Now, if you're going to want to keep your texture on the object, you cannot turn on Dino Topo. So if you're going to modify the bottom plane we created somehow, you have to make your own manual cuts in there. But otherwise, if you don't care about the vertex colors, you can go down here and turn on Dino Topo for the brushes. And because this one doesn't have vertex colors, but if it did, it would ask you, it would warn you that all that would be deleted. And then from here, you can, for example, color pick. I would put this to subdivide collapse and this to constant detail, and then you can color pick the detail of the mesh. And with your brush, it'll emulate that. So you can see now we can sculpt in the bottom plane, add some more geometry, and have that look okay. So with your object that would be really big, and I would suggest you use something like the flat brush or this on really high auto smooth and low strength. So all it does is create planes. You can also use this so if you have a particularly detailed area, so let's lower the detail. So if you have a really detailed area that doesn't need to be detailed, like the forehead, you can select that area just to get an idea of the detail size and up that a bit to remove the detail. So if you're using the auto smooth here, it won't really move things around much. It'll just subdivide, collapse all these polygons. One thing to note though is if you put this too high, it'll start to do something really weird. You can't really see it here, it needs to be even higher. So it starts to do something like this. So when you're using a really detailed model, only go up like maybe 0.5%. So here the effect is exaggerated, but on the model, if you went up maybe 5%, you'd get this weird effect. So only go maybe 0.5 at a time. And then from here you can do whatever you want. Move around the nose. For example, I made the nose on mine slightly smaller because I thought it was too big. I also used the grab tool to make it a bit more symmetrical. Be careful though, I just realized that I had symmetry turned on here. So don't sculpt with mirror on, turn that all off, because you'll have some natural asymmetry in your model, and if you tried to sculpt with symmetry, you would just ruin the other side. So yeah, you can edit the model even further and have it look even nicer. And then once you have what you like, you can go ahead and retopologize that if you want, or do whatever you want with it. Anyways, I hope you enjoyed the video and found it helpful. If you have any questions, leave a comment. Otherwise, please consider subscribing or following me on any of my social media sites. I also have a website, and if you want to help support me, you can check out my Patreon.